Up next, we have our final, last and final team. They come all the way from New York, Maine, Boston, sorry for that. Suffolk University Team JCR. They will be presenting on improving the solar capabilities of Cuba from an energy perspective. The team members include Mr. Christopher Villar, Roman Diak, and Justin Bassett. Their faculty advisor is Dr. Stephen Jones, with industry advisors Manuel Cerejo and Juan Belt. So please welcome them onto the stage.
So good morning, everyone. Once again, to reintroduce ourselves, my name is Christopher. Behind me I have Roman, and behind Roman is Justin, and we are all electrical engineering students at Suffolk University. And today we will be presenting to you our proposal called Keeping Cuba's Lights On with Solar Power. So to begin, we will want to give you guys a brief background on the current state of Cuba's electrical grid. Cuba's electrical grid is pretty old, and it's not very efficient. They tend to have a lot of transmission losses and a lot of blackouts on a very consistent basis. Between the mid-1950s to around, I believe, 1991, Cuba imported a lot of their oil from the Soviet Union in order to generate the power. After the fall of the Soviet Union, Cuba looked to Venezuela for their oil imports. As some of us may know, Venezuela is currently going through an economic and political crisis. So as a result, Cuba no longer can resort to Venezuela for oil imports. As a result, Cuba now has to look within their own nation for methods of generating clean and renewable energy. Also as well, I also want to add that a lot of the oil that they actually introduced from Venezuela, it's actually a high sulfate content oil, which isn't very good for a lot of the power systems that are used because they downgrade the systems over time. And as the population in Cuba increases, as well as the energy consumption, Cuba has to improve their energy sector in order to accommodate the additional load that we will see in the future. So behind me, you will see a chart now of Cuba's power consumption breakdown. These numbers are from 2014, give or take a few more percentages just because this is 4 years old. But we can see that almost 80% of Cuba's power generation alone comes from oil, and only around 5% actually come from renewable energy sources. Cuba has signed the Paris Agreement, so we do know that they do want to take an initiative and they want to contribute to renewable energy sources and promote it. They have stated that by the year of 2030, they want to be able to produce around 24% of their energy from renewable energy source. So we want to sort of give them a little insight of something that could be applied, and hopefully they take it into consideration in the future if they wanted to.
So providing the issue that there is a lack of efficiency and reliability within the electricity grid for Cuba, our team went ahead and decided to pursue the route of expanding on renewable energy and combining it with pre-existing wind turbine systems in certain remote locations that are accessible, that we carefully studied on the map of the Cuban island. So we're planning to establish solar fields roughly ranging in 10 to 15 megawatts of power outputage that would be combined with pre-established wind turbine systems that will be later explained by my colleagues in the presentation. We're also seeking to pursue an environmentally friendly resource of energy, considering the growth of tourism and being cautious about the wildlife. So installing solar farms would be an optimal and ideal solution to further expand the efficiency and sustainability of Cuba's power grid. Why solar energy in Cuba? Our group considers and strongly encourages the Cuban government to invest in solar and combining it with wind turbines because of the ideal location next to the equator and good irradiance numbers. We're focusing on the province of Holguin and in the town of Gibara, which in 2004 their population was 72,000. So we're specifically working with that region. Considering and taking into account a limited and finite amount of funds as resources, as well as land area footprint, we decided to study various options of renewable energy and came to a conclusion that solar would be most optimal and efficient per area, as well as per dollar value per watt. One thing important to include is a system that is, any system that is installed will require maintenance and careful, restoration, or basically cleanliness. And we compared solar fields to wind turbines costs. So depending on the variety of a solar panel, a 1 megawatt system would roughly cost between $11,000 and $17,000 per year to maintain. Whereas a turbine system, we were looking at a 1.5 megawatt GE Chinese wind turbine with an output of 1.5 megawatts that takes roughly $87,460 per year to maintain and visit the site and have the wind turbine fully functional. So to get back to the optimal and ideal location, and the reason why we were promoting to use solar energy on the island of Cuba is due to the ideal location close to the equator. And here's a quick, here's a quick graph of the average kilowatt hour of energy from sunlight. So this graph is designed basically for a space of 1 square meter. So this is basically explaining assuming you have a 1 by 1 meter solar panel, and they're describing the average irradiances for 22 years. And this data is gathered by the NASA Atmospheric Data Center, and this is a 22-year average of the region we're actually claiming to work with. And you can see that the average per year is 5.6 kilowatt hours per meter square per day. So if we compare this with Germany, who recently set up a gigawatt factory, their irradiance rate per square meter is an average for the entire country of Germany is 2.9 kilowatt hours per meter square per day. Southern California averages between 4 to 5 kilowatt hours per meter square per day. So here we see good numbers at 5.6 kilowatt hours, and this is in the town of Gibara, close to off the shore of Velasquez Beach, basically.
So when determining the ideal location to install these solar panels, we looked for 4 unique features when determining the specific location. One, we wanted there to be pre-existing wind turbines. The whole idea of our proposal is to integrate wind turbines and solar panel in order to maximize land usage. In addition, we wanted the land to be cleared out. This minimizes costs. In the general construction of wind turbines, land has to be cut down for the transportation of the rotors. So this, by having clear land, it kind of would minimize the cost of also solar panels as well. In addition, we wanted this location to be accessible. We wanted to introduce this project with the idea of making this a very feasible application. We want it to be something that can actually be affordable. So we looked for roads that are already pre-built in order to minimize the cost of, again, for a project like this. And in addition, we looked for a location that already had a substation in place. We can assume, since there are wind turbines, we can almost guarantee that there is a substation nearby that transmits that energy back into their electrical grid. And when determining our location, we finalized on a beach called Velasquez Beach that is 1 to 2 miles away from Jibaro, Cuba. And as you can see in the picture, those blue circles that you see, those are the current 6 wind turbines that currently exist. To the left of the wind turbines, you will see a red square. That red square is our proposed area that we would want to set up the solar panels at. So this land will be approximately 762 meters by 305 meters. This should accommodate approximately 82,500 solar panels, and it would generate just roughly around 12 megawatts, give or take, at peak capacity. And it could potentially power on at least 3,400 homes. These numbers are pretty rough. These aren't exact. We weren't able to locate exact data for Cuba on items like this, so we had to compare it to other nations with similar solar irradiance levels in order to give a rough estimate of what this system could potentially output. And in these pictures, you can see of a current solar farm in Germany, which has a very similar, I guess, design to the one that we want to propose, a very linear setup where the solar panels are sort of set up in a parallel fashion. This also pretty much maximizes the land usage and allows us to pretty much install these solar panels in a very compact fashion. And they will be set up on metal railings as well. That would give some flex room. Since Cuba is a tropical island, we kind of know that there is going to be some strong winds every now and then, and they go through natural storms. So by giving these metal racks some flex room, it actually allows the system to be a little bit more stable, which we figured out from our research.
Another reason why we think that solar is a great supplemental renewable energy source is because the average wind speeds in Havana are not that great overall. 26.5% of the time, they don't produce enough energy for the wind turbines that they have to produce less than 13% of their max output. So a quarter of the time, they're barely producing little to no energy based on like the power curve of some of the wind turbines that they use in Cuba are a lot of Chinese technology. Those 6 that he was talking about are 6 750 kilowatt Goldwind wind turbines. So 13% of that is less than like 100 kilowatt hours. Havana specifically has very low wind speeds. Sorry. As you can see from the graph over there, there are a couple places where they have more wind, but for the average is pretty low. Compared to solar energy in Havana, wind turbines produce electricity almost 11% less often than solar would in that instance. Solar versus wind output, this is based off like a 60 per 60 acres. It produces almost 3 times as much energy in the same area. This is based off the fact that wind turbines need to be spaced out a certain amount. For static setups, they're usually all in like one line. They have to be spaced out about 7 times the length of the rotor. And for the 750 kilowatt Chinese wind turbines, that's about 50 meter rotors, so it's between 350 meters they're supposed to be spaced in order to be the most efficient, have the least amount of wind turbulence. Again, the area usage, solar uses approximately 3.5 times less than a static wind turbine setup where they're all in a line, and 9 times less space than a multi-directional wind turbine setup where they're made to change the angle of the wind so they get the maximum efficiency from the wind. Cost of solar versus wind. We couldn't find a reliable source in Cuba for actual prices, so we based it off of U.S. pricing for the actual product itself. Between 85 cents to $1 per watt is pretty typical for the cost of solar panels. And for a 1.5 megawatt GE wind turbine, that's a pretty common model. It's approximately $3.3 million, which is about $2.20 per watt compared to the 85 cents to $1 watt of solar. In conclusion, we think solar energy is a great renewable energy resource for Cuba. They already have some solar and wind, but if you can implement solar and wind in the same area with kind of like what he was saying, the area is already pre-cut, there's already a road, there's substations involved. It would reduce the cost to already just tie into the electrical infrastructure that's presently available. And it would also minimize land area usage. Cuba's not the biggest country in the world, so they don't have the most land. They can't afford to just, make massive solar farms like in Southern California and out west in the United States. And I think that's about it.
And before finishing off, we just want to thank our electrical engineering professor, Dr. Schatz from Suffolk University. She actually was the one who actually told us about this competition, and she convinced us and suggested us that we participate to get a real-life experience. So we want to thank her for her feedback throughout the process of this project. As well, we want to thank the Association of Cuban-American Engineers, as well as the Cuban-American Association of Civil Engineers for taking the time to listen to all of our proposals today. So thank you very much.